We're good? All right. Sweet. Let's kick it off. I have lots of time to learn about daemons. Welcome to the Go Utah, or the Utah Go user group. I'm Brandon, so I'm going to be kicking us off today. A reminder that the door boxes above you with the green lights are mics. They pick up a lot of stuff. If you whisper, you'll probably end up on the YouTube video. Want to be YouTube famous, then go ahead and have whispered conversations. Otherwise, try and wait till the end. If you want to speak here, we've been doing a lot of Go standard library stuff. Today's not a standard library thing, but it's sort of like a basic Go thing. Go is pretty universal to anybody doing web services in Go. So, which is a lot of what Go is. So if you have something low level, kind of like, or not low level, if you have something sort of cross-cutting like that, that's sort of what we're looking at. Talk to me, talk to Carson. You can hit us up on the Forge Slack, and we can help you get a speaking slot. So I think this month is covered, next month is covered, so you be 2 months out. But come talk to us. We want to hear you speak. Jobs and hiring is in the Forge Slack. If you want to join the Forge Slack, you can talk about if you need people for your company or if you're looking for a job. But also, it's a great place to hang out. We have a bunch of fun channels there. There's a random channel. We talk about Go, the Home Lab channel, basically anything that you want to talk about tech-wise is going to be there. And all of the other meetups, all of the other events that are happening sort of end up there. So one place to be, join the Forge Slack. Go West is coming up in October. I have been told that this is the very last day to submit a proposal. Make sure it's good though, because they already reviewed the proposals. So if you submit one tonight, it's got to be worth Mariah's time. So, but yeah, so that's going to be good. We'll start talking again about that.
The tickets go on sale July 1st.
Yeah, I was going to say we'll talk about that more when tickets are up fairly shortly. And
all right, thanks, Brandon. You guys can hear me okay?
Yep.
Awesome. All right, well, my name is Roman Kupro. I am a fairly, not necessarily new, about mid my career, about 6 years I've been doing software development, which incidentally had started at Utah Go meetup. So a lot of folks here that are present, I've been more or less in touch for the last 6 years, or even more since the beginning when I started learning Go. Love Go, love our meetup, which is there's not too many of them out there. So I'm glad to be able to present. All right, let's start. I guess today's topic is how to shut down a daemon in Go. Or any language, really. The sequence is going to be fairly, what's the word? Identical, let's say. And I have to say, I've been doing software engineering for 6 years now, and not that I haven't really had an opportunity, but it's just now after 5 or 6 years that I've actually got to a point where like, oh, hey, I have been not shutting down stuff correctly this whole time, or I never paid attention to this part of the process. So it would have been nice if I've known about it earlier, but it's the software development such as it is. If you stand up a daemon, you do it once or twice at your job. You rarely just churn them out, every 2 weeks. All right, so let me get to my presentation. Oh, I need to share my screen. It's fairly basic and short. I think it's here. Here it goes. Oh, their entire screen. Here we go. All right. So, demons, man. I also refuse to call them daemon. I think it's a demon. Hope If it ruffles your feathers, then so be it. I'm sorry. So as they run, there's a lot of things that can go wrong, right? User errors, programmer errors that can result in panics. Definitely, most of the time, programmer errors. Yeah, they have to contend with the operating system or your deployment schedule, all not at the same time, but all of those things that you know can happen and they will happen at some point. So if daemons ran in vacuum, that'll be one thing, but they tend to take resources. So we are connected to databases, data streams, um, observability frameworks, and all of those things are connections or resources that were registered somewhere. So they're taken up. We need to manage them, not only when we start up a daemon, but also when we shut it down for whatever reason, right? So um, what are we going to do? Some low-hanging fruit, right? When it comes to shutting down, it reminds me the basic rules for shutting down in Go or in any other language, really, is what my Aunt Olga used to say about staying in her place. Once you're done, you put things where they belong and you clean up after yourself. So, and it's common sense. So the low-hanging fruit, the lowest of the easiest to reach would be to um, close up all of your resources that you've opened up. So specifically, anything that has a closed method that you've touched, you probably should call that. Databases, pools that you've opened, connection pools to databases come to mind right away. Yes, so just for that, there's a beautiful function, big beautiful built-in function that Go has called defer, and we'll be leaning on it heavily tonight. So the next thing, obviously, is to close up the incoming connections. As you're shutting down, you don't want your load balancer be counting you with the incoming requests that will only result in what's the service unavailable error. So, and especially if those are not reproducible requests, if the clients are not watching, which is, you should always be expecting that they're not going to be waiting on to resend the request to you, then you probably should make sure that you're not just chucking those requests by not addressing them at all. Then, since we live in the physical universe, it takes time for light to propagate as well as electrical signals. So each of the coming in requests that comes in, incoming, that's a good word. All of the incoming requests take time to be processed. For some, it's milliseconds, for some it could be seconds. And your shutdown sequence can initiate at any point. So there's a good chance that as your daemon's running, there's going to be some in-flight requests that need to be handled properly. There's nothing wrong with them. If we can finish them, we absolutely should. And then finally, panics. Those are always fun, irrecoverable errors, right? So when that happens, when a panic happens, everything just gets dropped on the floor. Daemon just poops out, and that's it. But that's not the end of the story. The connections that the programs that would be sending work to your endpoint. We have a post function that I'm using. All I'm doing is sending the number of requests in the body of the request. That's pretty much it. If there's any error, then we're sending it to the error channel. The only thing that we care about, there's nothing special about it. It's just at the end it counts how many requests have been sent and or failed, and then will give us a little bit of statistics. So let me start it up, and we'll go with the most basic situation. And I apologize, this is going to be a bit repetitive. So right now we've started our server, fake database has been connected, and then we'll start go run client. So this client will just keep sending payload at every half-second interval. Our server will process those payloads at 33% latency. So it'll take 3/4 of a second to process. So there's going to be a little bit of lag. So now we can, I'm going to send the termination signal, Control C, on the server. So our server is failing. So normally you would have a termination signal used by during a redeployment when you're shutting down older images and bring up newer versions. So here we go. All right, so wonderful. So what do we have here? We have had 85 requests, 56 succeeded, 29 failed. That's a bit. So in real life, this would be 29 people and or programs that didn't get their share, that there's nothing wrong with them. They didn't get any proper response. We can do better. At the end, let me see if can you guys read this here, maybe like that. And it's right here on the server, right here. So when you start a DB connection, just go ahead and defer and close. This will put it right on top of the stack, and once the function terminates, it'll be the last. Well, a side note about defer. Defer statements organizes your execution and first in, last out FILO manner. So the most recent defer statement will get executed the first at the end of the main function execution. So right now we don't have any defers, so this would be the only one that would be executed closing the database. So, all right. Is this making any sense so far?
Yep.
Okay. All right. Moving on. So we closed the database. So now we need to make sure that we don't get any requests sent to the daemon once we know that the daemon is shutting down. There's no need for that to be happening. So I'll have boom. And I know somebody might think, oh, look, he used Graph GUI for dealing with version control. I think it's okay. So, all right. So what we've done here now, we've implemented this endpoint. Correct me if I'm wrong, but in most orchestration services, you would have an ability to check the health and the liveliness of a daemon. So through an endpoint that would get sampled at a certain interval. So, so this is where I simulate a very basic version of that endpoint. So if everything's okay, this endpoint would return status okay. And if we know we're shutting down, then we're or unhealthy, then we'll return, service unavailable. So to this end, we have produced a atomic bool that was a global variable, and as soon as we know that we're shutting down, we're setting it to well, probably should have made it more positive. So we're setting our healthy to be false. So we're not healthy anymore. We're shutting down. After that, it's preferable to wait, and your wait time should be at least the amount of time that your health check, the period of your health check is. So if your orchestration platform is checking your daemon health every 5 seconds, then this should be at least 5 seconds. That way, it would let the load balancer know that we should not be sending this. It'll be just enough time for the health check to happen, and for the load balancer to know that to understand that this endpoint is no longer available. So, all right, let's rerun this. We'll run the client again. Again, starting up, and we'll send. I set up a couple of some endpoints here. We'll send an error. This would simulate an error. Ta-da. So what happened? We had failed much less now, much fewer. We also didn't send as many requests as last time, so we only had 6 failed. If we look at the logs, the first 15 requests have been processed, work as usual. Then we had an error that happened, and then we had 3 more requests that happened to complete during the grace period for the shutdown, when we were waiting for those 2 seconds to alert the load balancer that our service is going to be unavailable. So that's good. We have probably made some money if we were in the money-making business with these requests. So we shut the load, and then we close the database. The last thing that's left is to clean up all of the in-flight requests, which will be in the next commit. Okay. There we go. Check out revision. All right. So in order and they should release the resources as opposed to just run wild for undetermined amount of time. So, and for that again, so unless I feel like for the most part, it's the default server that gets used when you serve HTTP, listen serve, and all we're doing here is replicating the our endpoints and providing the handler. The only reason we even set it up, expose the server like that, is to provide the context for the incoming requests. Then once we know that we're shutting down, there are 2 things we need to do. First, we cancel out the requests. We'll start canceling the requests that we have, shut down the connections, and we do it through the shutdown method on the server. However, for this shutdown method, one of the functionalities that it has, it will shut down all the incoming connections, but it will wait for the current connections to become idle, to be done indefinitely. So we definitely don't want to wait or having a possibility of waiting indefinitely for those connections to end. So we want to corral it a little bit with a timeout. So we'll produce a timeout context and feed it to the shutdown routine for the server. There's a little bit more to do. You can do fancier stuff. There's another method called register on shutdown, where you can provide specific logic for something that's more complicated, like your socket connections, or if you really want to do something fancy. But for right now, all we're doing is shutting down. So if the shutdown happens normally, then without an incident, then the error will be nil, and your daemon is shut down gracefully. If the context times out, then we'll give it another 5 seconds, just because we're nice, an extra grace period. And if that doesn't happen, then we'll just force cancel and just consider those requests dead, or just write them off essentially. So if
Hey,
that
Roman.
makes sense. Yeah.
I just had a quick question. I know that you said that you should set the shutdown timeout to be at least as long as your help status probe. Do you have any advice for how to set the timeout for how long you should let your server shut down, like that timeout on line?
Yeah. So, I mean, these would be network calls, right? And for each application, that would have to be different. If I were to implement that for my own service, especially on the production level, I would probably look at the logs and look at where like 99.9 or as many nines as you want of your requests fall for their latent execution time. And then I would use at least that much time. So if 99.9% of my requests and are completed within 2 seconds or 3 seconds, then I'll give them that much time to complete. So again, this is separate from the health check, which is a pretty cut and dry. This is more of I guess more art than science, but also kind of science. You just look at what your rations are, like that.
Yeah, that's helpful. Thank
Okay.
you.
So let's see, I want to make sure we're in the right branch, right commit. Okay, so let's run this, and there was a way to automate this, but honestly, I just did it by hand. All right, we can send a signal. I'm gonna press Control C right now on the server, and beautiful. So awesome. our daemon just dropped everything on the floor and walked away. For that, we have a solution. Okay, there we go. Handle panic. Let me see if I can just show you the only thing that we've done here. The only difference that happened. Well, we'll just go back and run it. So the difference that happened is we deferred our all of this logic. We're going to defer it right after we start up our server, which may be a bit contrived thing to do, but it works. So we go. If you see, so we have I created a new function called Graceful Shutdown, to which I pass our server and our base context closer function, and this is it. It's the same thing that was behind this shutdown signaling logic, but now it's been deferred. So anything that can happen here will the shutdown logic is guaranteed to complete, including the panic. The only thing is we've added is a panic recovery from panic, which I guess was over here, but can be in a different spot. All right, so let's, and I know it'll work because I've already done that. We'll run the server, run client, and now sending a panic. Oh, panic. Hey, we're recovering. So our client knew that the server has gone bad and stopped sending the requests. Our daemon had recovered from panic. It shut the load, so indicated that no more requests need to be sent to it. So that's basic kind of playbook. The last thing is, just to reiterate the sequences, we first want to do when we're shutting down, we're stopping the incoming requests, processing everything that's up in the air right now, and then finally close up all the connections to our databases, Kafka clusters. I don't know, what do you call them? Stores, key value stores, or caches. So that needs to be closed down at the end. And that's pretty much it. Why not? Since we ended up having Go routine go-routines running around. So so I just called a panic right inside the daemon itself, as if it was some business logic that panic, like an outbound slice or dereference or something, which unfortunately happens more than I'm willing to admit. So yeah,
Even in an
this
HTTP service, there's probably like background processes that might be running or other stuff that could panic that's not in the context of handling a request, right? And this would catch that.
right. This would be a panic that would be not in the request itself. Well,
Basically, anything fails at this point, right?
yeah, it's something that would trip your normally you would see it if you deploy it to Kubernetes, there would be a crash loop that would just start up a daemon and crash it. So that kind of panic. So not necessarily associated with the HTTP request, but maybe the data inside the HTTP request that caused it, that was propagating through your business logic. So that's the kind of panic that we're talking about here.
Roman, is this code going to be available?
Yeah, I will post it. I don't know if you want it, but I'll
I think it's
post
nice
it.
to be able to review. Yeah.
So it's a little contrived in the way that again I wanted to add a lot more visibility, counting the routines and stuff. So it ended up being was a bit more dendritis on it than it should have, but at least it was nice to see it. Counting down.
I was gonna say, I don't think this was even in the standard library. I don't know when it got added, but I just saw that there was also a method of the what's it called? The shutdown hook, that you can give it or it gives you back a context and a shut or a cancel method instead of having to passive channel. So if you wanted to use the man, I think I have a tab up with me. I can't even remember what it's called. But anyway, you can use the OS
Signal context.
Yeah, notify context. So instead of like passing things, you can actually use notify context, pass an apparent context signals, and then you get back a context and a stop function, and then you don't have to use channels if you don't want.
Yeah, so I saw that too late. I was already too deep into setting up this way, but I have noticed in some, yes. So the thing that happens is it just cancels the context. So you're only dealing with, instead of dealing with this kind of a nightmare, not nightmare, but just this kind of implementation, you're just dealing with the context done. So the signal channel just done to your context, and you get a receive on that channel, which is, I think, is a good solution. Like, there's no reason to not do it, honestly, just for cleanliness sake. Yeah.
It's also like a nice pattern, nice to see the standard library, and then you could be like, I can pattern my own shutdown kind of, or notify kind of thing using either a passive channel or a text. I like learning that.
Yeah, I just personally, the reason why I think I prefer this approach more, because it does not mix context cancellation with OS signals, which is fine. I mean, they all result in the same thing, right? But like, why did this context just get canceled? Is that something that
Yeah.
I was gonna say, we expose, you could do a context or a channel, like if you have a worker pool or something that doesn't necessarily have like a graceful shutdown in the same way that a server does. And then the daemon can say, hey, start, shutting down nicely. It's the same thing, but most of them don't have necessarily that same shutdown, and then it handles the waiting for in-flight requests to finish.
Are there any good like packages or libraries that do, like a lot of this was like pretty raw Go, which is great for learning, but is there like a production thing so I don't have to write a bunch of channel and context stuff myself?
I should publish ours.
Yeah.
The
I was
nozzle
just
version.
gonna say that. I got used to that.
I've shared it with a lot of people.
Yeah, I
If
mean,
only
we
there
had-
was some way that I could use a GUI, make it available, open source.
But there isn't. Else. Or just SVN.
Emailing patches.
Bust out your floppies, you guys.
I think you should just start sending all of them.
Mailing discs. Absolutely, absolutely. I can automate that way easier.
I've got I guess maybe this is just like a design question and not directly for like Graceful Shutdown, but like I was just thinking about like in the case where let's say you do have an HTTP server and one of the handlers starts throwing or panicking, but not all of the requests are throwing and panicking. Do any of you like keep track of like I don't know, even internally in the service itself, keep track of like a certain metric at which point the server would maybe tell itself to shut down or say, mark me unhealthy because a certain percentage of my requests are failing? Or is that too,
It always sounds great. There's about 1 million horror stories online of Kubernetes readiness probes being misused, and almost none of them, no stories of them being used to success. What you're talking about is sort of a version of that where you're like, oh, the whole service must be bad. If enough requests happen, that I hit some threshold, like I'd rather get no traffic than that's almost never true. Like you almost always like if 90% of your requests are failing, it's still 10% are processing. Whereas if you shut the service down and nothing else is there to replace it, now you've got 100% of your services, of your requests failing, right? So like,
Just to say, is that one pod or is that all your pods? Because if it's just one, then maybe, but if it's all of them, then
then you get to
you're
zero service failure.
anyway.
The right spot is at monitoring, and you do auto rollbacks.
yeah, that's probably.
Not in the,
Yeah, usually it's like you want to alert on that rather than start automatically shutting stuff down, right?
Yeah, what we do we have, a standard middleware that does defer. So if like a handler panics, we catch that early in our own middleware. There might be a default one, but we definitely have our own that catches, does defer, catches the panic, recovers from it, emits certain logs, increments certain metrics, and then we alert on that. So you can notify, sort of like if any of your handlers panic, you'll get an alert on this because we catch panics and increment a metric about panicked handlers.
And a progressive rollout either on a metric or load balancer. So like Envoy calls it outlier detection. So outlier detection would catch your, hey, this thing is starting to get more 500s. Maybe
Yeah.
it shouldn't continue the rollout and should go the automatic rollback. But I wouldn't bake it into an application.
Yeah.
Let the system solve it instead.
Okay, well, thanks.